Okay, the last standard locus that's within your syllabus will be what we call the half line. The standard equation of half line look like this. Argument of z minus a is equals to theta. So again, going back to your understanding of interpretation of argument z minus a, it is the angle or the argument of the complex number of z as measured from a. Okay, it's the angle of the complex number z as measured from a. So if this is where a is, okay, the argument of complex number z as measured from a must be angle theta. You actually generate a half line that shoots off from point A and goes on indefinitely. Okay, so this is your what we call the description. Let me give you an example to run you through the theory. So for this one, argument of z is equal to 4 pi over 5. So the interpretation of this is that it's actually argument of z minus 0 is equals to 4 pi over 5. So in simple English, okay, I want to know where the complex number is such that the argument of z as measured from 0, which is origin, is always 4 pi over 5. So this is where 0 is. And then I measure off 4 pi over 5. This is where my complex number or locus is. Okay, it's going to be a half line starting from origin, making an angle of 4 pi over 5. So again, what you must draw is, you must indicate the angle. You must indicate for me an open circle. 4 pi over 5 must be there. Open circles must be there. Same thing, equal scaling. Okay, that will be the first one. How about the second one? So same thing, you do some adjustment. It is argument of z minus away 1 plus I equals to negative 3 pi over 4. So the starting point will be 1 plus I. Okay, 1 plus I as measured. Okay, I want to form an angle of negative 3 pi over 4. So as measured from 1, 1, I must have an angle of 3 pi over 4. Negative. So negative means anti-clockwise. It means clockwise. Okay, so this is the red line is where my locus is. So take note, it passes through the origin. Okay, so what you must draw again, open circle, label 1, 1, 3 pi over 4 with a dotted line telling me that is the locus. So the last one, readjusting it, minus 2i, okay, must be equals to pi. So the starting point of this locus will be minus 2 minus 2, making an angle of pi. So it's actually a horizontal line, okay, coming through this way. Angle that we measure is actually just pi. This is where my locus is. Okay, so if I actually ask you to find the Cartesian, okay, I ask you to find the Cartesian equation of these three lines. Okay, make a description. Let's try the description first for part 2. The description of part 2 is actually, it is a half line starting from 1, 1, making an angle of negative 3 pi over 4 to the real axis. Then, if I want to know what is the Cartesian equation, so same thing, you fall back onto the secondary school knowledge. I have a point, I have an angle. This angle is sufficient to give me the gradient of this line. Okay, how to find the gradient is actually tangent inverse 3 pi over 4. Okay, tangent inverse 3 pi over 4. So the equation of the line is just y equals to x. But what is very important, like your functions, you must tell me when is it valid. It is only valid when x is smaller than 1, because it's actually a half line. Okay, so I cannot take y equals to x indefinitely. I can take y equals to x with certain domain of x value only. Similarly, for this example, a Cartesian equation is y equals minus 2, where x is smaller than minus 2.